we haven't actually released the arbitrary message passing bridge yet. It's already in GitHub, and you can play around with it, it works. But we want to write a few more integration tests, and then I expect us in the following weeks to release it, then deploy a test version between Coven and maybe Rupston, right? Play around with it, invite more people to play around with it, see if it really fulfills these requirements and meets these needs that people have. And then once we got there, sure, like definitely, either we do it or we team up with a few teams to audit these contracts.
Thank you.
Yeah, thank you for the question. Hi.
Hey, thanks for that, Bjorn. Thanks. It looks really exciting. One question I had was with the bridge authorities. Who do you envision those would be? Like, what are the incentives for actually securing those relay messages across screens, across chains? And how to punish bad actors that might seep in.
Right. I can envision multiple scenarios, right? Number one, the most obvious one is the DApp that needs to utilize the chain, right? Being it their own chain or the multiple DApps that want to spin up their own chain. They have an intrinsic motivation to, facilitate this transfer. And after all, the price isn't really the problem, the cost, the expenses. To spin up a node today, I believe for Ethereum mainnet costs like, what, $150 a month to run a node? So that isn't really the point. And to my knowledge, I think POA Network has been running the bridge for over half a year now. And I think the costs were negligible. So,
the reason I ask is one of the most exciting use cases, which I've thought of with something like Thundercore or something like that, being able to use DAI, say on one side chain, move it over. You can end up if some application becomes really valuable or really of high use, right? These bridge authorities are going to be presumably taking in DAI and being able to direct it in the main chain. There might be a lot of value moving from one chain to another.
That's it, right.
And so, obviously, there's an incentive. There might be an incentive there, right, for then to direct DAI to some other contract that's not the intended contract.
Right. Multiple aspects, right? I still think this is only an intermediary solution, as I said, because I think we need to come to a point where we pool security for all these chains, right? This multi-chain future where you have like thousands of chains that all secure themselves, be it in this model, right, where you have EVM chains being bridged by Parity bridge, or in the Cosmos model where you have all these zones that have to secure themselves. I don't think that's feasible in the long run, right? For me, this is really an approach for all these applications right now that are facing these issues that they have been working on all that code for like multiple years, and they are facing the situation, either you wait another 3 years until Shasper is here, or you restart from scratch and try to implement it with layer 2 solutions such as state channels, right? That said, I'm not quite sure if that, are you asking about the danger of having too much value locked up in a POA chain?
Well, maybe not necessarily POA, but for instance, like you could mint DAI on the mainnet,
right? And
then there's some application that uses DAI, say on another chain. Maybe it's like Proof of Work saying or Pivotella or something, right? And you send, I don't know, $1 million into the other chain, right, through the bridge. Value gets generated there or whatever. Then you want to secure it back on the mainnet. You want to send it back. You want to make sure that that's, destroyed or properly accounted on the mainnet. But maybe it's just not the right use case for this kind of bridge.
No. Okay, I get it. So you're asking, how can I trust these authorities?
Effectively, because they can send it wherever.
That's always the case, right? Like it's the same thing as in Ethereum proof of work or in any kind of proof of stake system. How can I trust that the validators who validate my chain, be it the chain or the bridge, doesn't really matter in that sense, right? Like don't collude, right? Don't build a cartel and say like, oh, I'm actually going to take all the value out of that bridge. Very good question. I think, like as a user, you got to be really cautious to interact with certain chains with too much value, right? I wouldn't want to transfer a million DAI over to a chain that I know is rarely being used, where there may be two authorities only that have aligned incentives to actually collude and steal your money, right? Yeah.
Thanks, Roy. Appreciate it. Thank you.
Thank you.
How is the fault tolerance maintained at the delivery of the accept message? Is there a ring signature or something of the validators?
No, so what is happening? The bridge authorities do two things, right? When they watch a message coming from main to side, on the side messages, they all have to call a function on the side network, right? And you have a configurable threshold, and if you say 7 out of 10 authorities have to sign off on the message, only then the message is actually being relayed, otherwise not, right? And in the other way around, you gather signatures before, right? They gather signatures on the side network, and then the last authorities submits one transaction on the main network that accumulates all these signatures, and the contract checks that all the signatures are there. In that way, you have like fault tolerance.
Okay. Is there like on state channels where there's kind of this a waiting period after a message has been relayed? Is there something like that so that maybe somebody can bring an attestation saying that actually that's not what happened on the opposing chain?
Currently not, because really you take the set of bridge authorities as your point of reference. If they say, hey, that message was relayed, it's actually relayed. And in order to make sure there's no reorganization, they wait a few block confirmations in order, to be sure that actually whatever kicked off this relay happened on the one side of the chain.
Thank you.
Thank you for the question. I got to head off. Thank you.